Good evening, everyone. Shiny from Mydbops here. Thank you for joining us today for the 37th edition of my webinar by Mydbops. Before we dive into today's topic, let me give you a quick overview of who we are. Mydbops is a leading database management and consultancy provider founded in 2016. Over these years, we have had the pleasure of assisting over 800 happy customers, and our services include comprehensive consulting and managed services tailored to meet your database needs. Today, we are excited to dive into the world of AWS Blue Green deployments for databases. This session will be extremely valuable for anyone looking to master seamless database deployments with minimal downtime and risk. During today's presentation, we will walk you through the core concepts of AWS Blue-Green deployments, internal workflows, and share best practices that will help you ensure smooth and efficient database migrations. Whether you're looking at version upgrades, performance testing with the live data, or database parameter validation, this session will have plenty of insights to enhance your database management strategies. Before we get started, I would like to introduce our speaker for today's webinar, Praveen, a highly experienced MySQL expert at MyDBOps. Praveen is deeply passionate about open source database technology and has years of expertise across both on prem and cloud environments. And we are excited to have him lead this session. And also, we encourage you to participate actively. Please feel free to drop your questions in the chat and we will address them immediately. Without further ado, let's get started. Over to you, Praveen.
Yeah. Thanks, Shani, for your introduction. So, hi everyone, good evening. So, I'm Praveen, a database consultant at MyVideo. Today, I will take about AWS Blue-Green deployment for database, a powerful technique that can be significantly reduce the risk associated with implementing new features or making changes in the live environment. Before diving into the detail of blue-green deployment, it's important to understand the common challenges we face when implementing changes in databases. These challenges are familiar to many of us who have worked on database management or maintenance tasks. So, like in that, setting up a new database environment, especially one that need to be production ready, really requires a lot of manual work and coordination. Each steps from configuring the environment to ensuring the data consistency. There is a like many complex process will be involved, and there are many room for errors as well. So, migrating data is another significant challenge. Moving data between environments carries the risk of inconsistency or data loss, especially when working with the large data sets. So these migrations are often performed under tight deadlines, means which will add more pressure and increase the chances of human mistakes. After implementing the changes, we often rely on the manual verification to ensure everything is functioning properly. These manual checks can be time consuming as well as can lead to human errors, which makes the process more stressful when it was at the meeting the deadline. So one of the hardest part of deploying changes is keeping the live environment synchronized with the test or staging environment. This becomes especially tricky when we handle the live traffic, because even a small misstep in routing can lead to a disturbance, because if we doesn't route the server properly to the new environment, it will start reading these ideal data. So adjusting these configuration is necessary to ensure users are directed to the right server of the application. So if not, it will be difficult for handling the traffic properly on the correct server. So finally, having a reliable rollback plan is crucial. When things go wrong during deployment, we need the fast and effective way to revert back the changes. Here, what we will be covering in today's presentation, we will start by understanding what AWS Blue-Green deployment is and how it works. Next, I will explain the internal workflow and the specific benefits this approach brings. We will then go over the prerequisites we need to have it in place before starting a blue-green deployment. After that, we will explore the common use case where this method can be more effective. I will also highlight some best practices to ensure smooth deployment. Finally, we will wrap up with the limitations of blue-green deployment. Let's now take a look at some practical situation where blue-green deployment can make a big difference. So these use cases highlights where this approach is particularly useful. Upgrading a database to a new version can be a risky process. Even after extensive testing, there is always the chance that something might behave differently in the production. So with the blue-green deployment, we can create a green environment to test the upgrade thoroughly without affecting the live system. Once we have confidence that the upgrade works as expected, we can switch over to the green environment, ensuring a smooth transition. Like launching a new feature can be stressful, especially if the test environment don't have accurate data of the production environment. At that time, also blue-green deployment allow us to set up a green environment that mirrors the live system, like giving us a live data for the testing environment. Once testing is complete and everything is functioning correctly, then we can switch to the green environment, which made the changes uh, effective seamlessly. In many cases, testing with live data is crucial to ensure that the new feature will perform as expected in production. Blue-green environment, as we mentioned earlier, like it will allow us to test it with the live data, which is without affecting or taking risk of live system. If we are changing important database parameters such as like memory or buffer allocation or index strategies. So with the blue-green deployment, we can test these changes first in the green environment. This way that we can observe the impact of those changes without affecting the live data. Once we are confident in the new changes or the parameter changes, we can move them into production by using switchover. So in the blue-green environment, it is great for the performance testing because it's have the live production data for the testing. Like so the testing of the new feature or the configuration, it is like we are testing on the real world condition. This helps us to ensure that we are not introducing performance bottleneck or other issues when the new environment goes live. So, what exactly the blue-green deployment is? Simply like it's a method where we set up a two environment, the blue environment, which represents the current live environment, and the green environment, which is the copy of blue environment, where we can apply the changes and test like untested. So it is the AWS Blue Green is supported for Postgres, MariaDB, and MySQL engines. It is also supported for the services like ODS and Aurora. Like it is like a full data migration, which means it's going to migrate all the data from the blue environment to the green environment, which is the complete clone of the current server. So whatever the architecture that we have it in the blue environment, it's going to remain the same for the green environment. If you are having one writer and one reader instance in the green environment, also the same set of architecture will be reflected. All these are a automated process. No one the option selection is on the end user other end, whereas the rest of the data migration process, the cutover process, everything are automated from the AWS end. As well as it's not going to have the stall data on the green environment. The live data sync will be there between the blue and green environment. So the incremental data will be reflecting from the blue environment to the green environment. So since we are having the asynchronous replication, there is a chance that lag will occur between blue and green based on the workload that we are performing on the blue server. So once we have finalized all our feature addition or changes in the green environment, um, we are easy we can easily promote the green environment to the live server, and the blue environment will be like uh, moved as the background server as we hold. So whatever the changes that we have performed on the green environment, it's not going to be reflected on the blue environment. So it is independent, like blue and green are independent. So whatever the changes is occurring on the blue on the data, it is going to reflect on the green server. But whatever the testings that we are performing on the green server, it won't be reflected on the blue server. So until this switchover is done. So post switchover also there won't be any contact between green and blue. Both become the isolated servers. So it like the green environment is completely customizable, which means you can upgrade the version or change the parameter group, change the instance type based on our convenience. We can customize the green environment. So let's dive deeper into how blue-green deployments work at a technical level. So the blue environment is our current live environment. It's running on our production workload, handling live traffic and holding all the real data. So it will have the topology details as well. So what is the current architecture, or how many readers or how many replica it has. So those analysis also it will be taken care. So AWS creates a clone of the blue environment to form the green environment. This green environment is the exact replica of the blue environment. Means it has the same data. By default it will go with the same configuration, so we can later change it. So then AWS keeps the two environments synchronized using the async replication, ensuring that any changes made on the blue is automatically reflected to the green. So the green identifier, it will have the unique name of it, the instance name, then the with the name of green and the random character of after that. So the asynchronous replication ensures that any data changes is performed on the blue, it's going to reflect on the green to make the data live. So then at the switchover phase, once we have done all the changes on the green environment and tested it, everything is fine. We can initiate the switchover, so which will point which will promote the green server as the live server, and it will move the blue server as old. So the identifier name of green will be renamed to the original name of the live server, then the identifier on the endpoint, and the blue one will be renamed with the name, the identifier endpoint will be renamed as -old. So now the blue become the old server and the green become the live server. So this is that internal workflow of that, like the blue architecture, the data copy will occur. Then once that new green environment has been created, the live sync will be configured between the blue and green. Then while switch over, the instance identifier endpoint will be synced. And finally, the blue server will become the old server, and green server will be ready for the production trial. Now, now we understood the internal workflow. Let's talk about why blue green deployment is so beneficial. AWS makes it simple to create an identical green environment. The entire process is automated, which saves time and ensures consistency between the two environments. This removes a lot of manual effort typically required when setting up the new environment. So one of the biggest advantage of Blue Green is that the level of automation it offers instead of manually applying the applying or preparing the server or a new environment, which can the data need to be migrated without any mistakes. So this one has been entirely automated, which reduce the human errors and speed up the deployment. So it has the live data sync as well. The green environment stays in sync with the blue environment through the asynchronous replication. This ensures that no changes in the live environment, such as new data or update, are reflected in the green environment. When we switch over, we don't need to worry about the missing data. So one of the another feature of that is benefits of that is like we can test the green environment without affecting the blue environment. So whatever the it's not recommended to modify the data at the green environment, but other than we are validation or performing the performance testing over in the green environment, like we can do the testing which won't affect the live blue environment. So, what are the changes that mentioned? Like if we are, even though we are doing the version upgrade or parameter changes, there won't be any impact on the blue environment, which is going to be performed as the isolated. So the data changes performed on the blue will be reflected to green due to the asynchronous replication, whereas the whatever the changes that made on green, it's not going to affect on the blue environment. So as a easy switch over. So as the endpoints are going to remain the same after the promotion, it's a easy switch over process instead of doing the application changes manually pointing to the new server. Here we can easily promote the green environment to the blue environment, green environment to the live server and blue to the old. So here there is no manual work is getting involved. So we need to choose the appropriate options for it. So it will automatically do the migration and the configuration of replication from the automated process. So the manual intervention is getting reduced. So due to that, the human error for the data migration or validation of the data consistency it is getting reduced. So we can make sure that okay, there is no error has been occurred during the time of cloning the data or post validation. So those manual efforts are reduced and human errors are avoided as well. So, data consistency will be maintained between blue and green by the asynchronous replication. So the data will be lively synced between blue and green. So in case of during the promotion, if it got it got timed out and failed, the it will come back to the same blue environment instead of promoting the green, because there should not be any long running query happening on the blue and certain limitations are there. So if anything is happening like that, instead of breaking everything at in between, it will fall back to the blue environment, which is a easier one. So prerequisites, like before implementing the blue-green deployment, there are some prerequisites we need to address to ensure the process runs smoothly. So for a Postgres, we need to we need to be using a supporter version, typically the version 11.2.1 or higher, for both RDS and Aurora. The version mentioned is common for both RDS and Aurora. Whereas in the MySQL, we need to make sure, like for Aurora, it should be greater than 5.6, and for RDS MySQL, means it should be the version should be 5.7 or higher. Then if it is RDS MariaDB, then it should be higher than 10.3. Additionally, certain configuration need to be changed, which is a max replication slot, max val sender. So these variables need to be properly set up before enabling the blueprint. And in MySQL, we need to enable the bin log because the asynchronous replication is configuring between blue and green. So the main source will be the bin log. So we need to make sure bin log is enabled on the server. And bin log format as row is a optional. So it's just not a mandatory, but it is when we are having replication concept, then row based is the best row format for deployment. So first we need to log into the AWS console and select the cluster we want to use for blue-green deployment. This is the starting a point for the building the environment. Then we need to initiate the blue-green deployment, but creating new deployment job. We assign the we need to select whatever the cluster we need to make this blue-green. We need to give action and select the create blue-green deployment. Then in that, it will request to provide the identifier name for it. So it should be unique for our account. Then in that, we need to choose the what is the destination version that we are planning to, and what is the parameter group and cluster parameter group that we are planning to choose it. So either we can choose at the beginning itself or go with the default parameter of the blue server. Later we can manually modify it on the green server. Then once we have finalized it, it will start provisioning the green environment. So once that green environment is done, we will get the label of a blue environment for the older environment, and green environment label for the newly spun green environment. So to once all the testing of new changes or feature addition uh, done performed on the green server, once we are satisfied with that, we can move on for the switch over. For that, we need to choose the option switch over. So during that time, it will give us the summary. So it will show that what is the source, source blue instance and destination green instance, and what is the timeout we are setting that we can keep it. So if the timeout extend more than this, then it will fall back to the same blue server. So suppose that when we are promoting it, we can see the status as switching over, which will show that currently the switching over for the blue green it is in progress. So once the switch over is completed, we can see that the green server label has been changed as new blue, which is the live server, and the instance name has been renamed to the original name. Whereas the old blue, the name has been marked as -old. So now the green environment has been successfully switched over to the new blue environment and start receiving the live data from the application. Now, best practices. To ensure that blue-green deployments run smoothly, there are few best practices that we should follow. Before switching over from blue to green, it's critical to check for any replication lag between the two environment because it's a asynchronous replication. If green isn't fully synchronized with the Blue server, we risk losing the data during the switchover. So we need to verify that green is up to date, ensures the smooth transition. And then, like it's important to double check that both the blue and green environments have the same configuration. Any difference in memory settings or like CPU configuration. So this will avoid us the surprise during the after the switchover. So in case of if we have without a proper analysis of server performance or the resource utilization, if we have directly reduced the instance type on the green server and we have promoted the green to blue, then post the green server went to the live production, it can face the performance degradation. So we need to, before downscaling the instance, we need to make sure that okay, the we have done it by knowingly based on the analysis of uh, resource utilization on the old the current blue server. So post the analysis, we can do the corresponding modification on green and we can promote it, which will avoid the unexpected surprises post the cutover. Um, then the infra changes or the parameter changes, we need to make sure that it's same. So if we are doing for a parameter tuning, then the parameter configuration can be different, but we need to properly validate and do the performance testing, load testing, everything on the green server before it has been switched over to blue server. So then in the blue environment, we should configure additional bin log retention, like retaining the extra bin logs helps preventing data inconsistency, like which means the green environment has broken, then the blue environment should not peruse the bin log, which will lead to reconfiguring the blue-green deployment once again. So actually, we need to make sure that we are having the the proper retention which will avoid the green server breakage due to bin lock bug. Then reducing the switchover timeout ensures that like the process is quick and efficient as possible. While AWS handling the switch seamlessly, minimizing the time it take to redirecting the traffic or the switchover, reduce the changes of the impact. If the timeout is we have set it as higher, then we need to wait for that much of time. Post that if it has been fall back to the same blue server, then the time invested will be higher for that. So instead of that, we can if we have set it as a lower switchover timeout, we can get the result earlier. So it can be based on the use cases, but as a best practices, we can have the lesser timeout value for it. So then the data consistency should be maintained properly. Like during the entire process, we should continuously ensure that both the environment or maintain the data consistent. Why? Because any inconsistent of data could lead to a failure during the switchover or the asynchronous replication can also get break. So we can modify the system configuration or the parameter group change. Those modification we can perform it on the green server, but the data modification is not a recommended one. So if we are planning for the a switch over, so at that time it's not recommended to do the data modification on the green server. So manual reverse replication. So it is just recommended if you are having the same version. Just consider only the parameter changes that we have planned to do it. So, but not the version change. At that moment, we can manually configure the replication between after promotion. So the green will become the new blue and the blue will become the old blue. So at time, we can configure the reverse replication between because by default, AWS won't configure the replication between new blue to the old blue once it has been switched over. Like once it has been promoted, there won't be any replication. But we can configure it manually by external replication between the new blue to the old blue. By this, in case of any failover or fallback, we can easily do it with the live data sync. So there are we have highlighted notable limitations. While a blue-green deployment, it's incredibly useful tool, but there are a few limitations. In that, I have highlighted the notable limitations of it. So during the blue-green deployment, in process, we can't stop or start the cluster. Like this limitation can affect the maintenance task. Whereas as well as the auto scaling policies, it won't automatically copy the auto scaling policies from blue to green environment. Then there are a few unsupported AWS services as well, such as ODS proxy or cross region read replica aren't supported in blue green deployment. Then currently the blue green deployment isn't supporting the global databases as well. Now, I will show the demo on how to do this creation of a blue-green deployment and the switch over for. So this is my AWS test console. So currently I have active writer and reader instance Aurora, which is at MySQL. So I will show the demo on how to create the blue-green from this cluster. So on the switch over for that. Select which cluster we need to enable the blue green and choose the blue green deployment. Then in that it will request for the identifier name. I will use the same but with the blue green. Then I'm going with the default version in the parameter group. So it will like since I'm not having any changes to be implemented on the green, so just I'm showing how to create the green and the switchover. So by default, I'm choosing the same version and the same parameter group of the blue server. So based on the data size, the timing will vary. So currently, the data size is lesser than 10 GB for me. So it will take little bit of time for the creation. Now the green environment has been created. Generally, the creation of a green environment will take time and it will vary based on the data size. So now, since the instance has been created, it has been labeled with green, and the older server, like the live server, will be labeled as blue. So as we have mentioned earlier, the identifier name, then the green means green, and the random character. So it will be named with almost same. So the server is ready with the same configuration in the parameter group. So now I will show the how to do the switch over for it. So once we have clicked the switch over, it will show the the summary and the timeout setting for it. So I will reduce to 2 minutes. So and give switch over. So it will start status will be changed for this cluster to switch over. And first it will start with the green. Now the blue is moving on for the switch over. So now all the servers we can see right one by one the step is getting changed. So green now the green server is moving to the front end for the live data like live application, and blue will be moving to back end like a old server. Now the switchover is completed. So the blue server has been mapped as hyphen old, and the green servers or mapping is it's not completely completed yet. So once it has been completed, the status will be shown as switchover complete. Yeah, it has been changed. So like the old server will be renamed as hyphen old. So on the new server will be the green server is promoted as a new server, and it has been came with the actual instance name of the uh, instance. So there won't be any need of application changes of pointing to the new connection. So the endpoints remains the same. So the blue server become the old blue, and the green become the new blue server to serve the live application traffic. So the demo for blue-green deployment and switcher has been completed. So these are the reference link. And like in case of any queries or doubts, please drop your queries in comment section. So we will address it shortly. Thank you for attending this webinar. And I hope this presentation has give you valuable insights into how you can use AWS Blue-Green deployment to improve our database management. Thanks everyone.
Thank you so much, Praveen, for that insightful presentation on mastering AWS Blue-Green deployments for databases. It was incredibly informative, and I'm sure everyone here has gained valuable knowledge on how to effectively manage database deployments while minimizing downtime and ensuring smooth transitions. I'd also like to thank all of you for attending today's webinar and for your active participation. If you have any further questions or need more information, feel free to reach out to us at info@mydbops.com or visit our website www.mydbops.com for more resources and upcoming events. Don't forget to follow us on social media to stay updated on future webinars, blogs, and everything database related. Once again, thank you, and we look forward to seeing you at our next MyDBOps webinar. Have a great weekend. Thank you.